Hello students of class 7. In this video we will learn about rotational symmetry. So rotational symmetry of plane figures, when the figure is turned about a fixed point, it is called rotation. This rotation can be clockwise or anti-clockwise. The fixed about which the figure is rotated is called the center of rotation. The angle of turning during rotation is called the angle of rotation. A quarter turn means a rotation of 90 degree. A half turn means a rotation of 180 degree. A full turn means a rotation of 360 degree. A figure is said to have rotational symmetry if it on to move then once during a complete revolution, that is 360 degree. Order of rotational symmetry. The number of times a figure fits into itself in one complete rotation is called the order of rotational symmetry. If a degree is the smallest angle by which a figure is rotated so that rotated form fits onto the original form, then the order of rotational symmetry is given by 360 degree. Given by 360 degree by a degree. Examples of order of rotation symmetry. The letter B clockwise, we observe that only at one position the letter B looks exactly the same after taking one complete rotation. So in here let's run angle of rotational symmetry. Angle of rotational symmetry. If a figure looks like its original after a rotation of x degree, then x degree is the angle of rotation. Okay, if a figure looks like its original after a rotation of x degree, then x degree is the angle of rotation. Now you see, this rectangle, it is rotated. Okay, this rectangle, it is rotated an angle of 90 degree. Okay, it is rotated by an angle of 90 degree. So it looks like this. And then again it is rotated by an angle of 180 degree. Now it looks like this. Okay. And then again it is rotated by an angle of 90 degree. Then it looks like this. And then again it is rotated an angle of 90 degree. It looks like this. We notice that the rectangle fits onto itself or look exactly as its original twice during a rotation of 360 degree. Hence, it has a rotational symmetry of order 2. Okay. Rotational symmetry has application in various fields such as advertisement, textile, designing, and fine arts. We observed that when a square is rotated through an angle of 90 degree, it fits exactly onto its original shape, and this happens every time it is rotated through an angle of 90 degree. Thus 90 degree is the angle of rotation of a square. So the minimum angle through which a figure has to be rotated to get an original figure is called the angle of rotation. Okay, the minimum angle through which a figure has to be rotated to get the original figure is called the angle of rotation. Now, order of rotation symmetry. While rotating a figure through one complete rotation, that is 360 degree, the number of times it appears exactly as its original is called the order of rotational symmetry of that figure. If n is the order of rotational symmetry and x degree is the angle of rotation, then n is equal to 360 by x degree. Okay, so this is B. Letter B has a rotational symmetry of order 1. Okay, because in one complete 360-degree rotation, okay, it looks exactly as its original, okay, in 360-degree. Okay, because you see it is rotated by an angle of 90-degree. It's look like this, which does not look at its original figure. Again rotated, it looks like this. It does not looks like its original figure. Again rotated, we get this. It does not looks as its original figure. Again rotated, then we get this, which looks like its original figure. Okay, so in one complete rotation, that is in one complete 360-degree rotation, okay, at 360-degree, it looks exactly like its original form. So therefore, you see, while rotating a figure through one complete rotation, the number of times it appears exactly as its original. Number of times in here, in one complete rotation, the number of times that it appears exactly to be its original form, it is only in the angle 360 degree. Okay, that is only in one time. Only one time in one complete 360-degree rotation, it only one time it looks exactly same as its original. Okay, so therefore it's rotational symmetry of order 1. Okay, B has a rotational symmetry of order 1. So it is not considered to have rotational symmetry. Okay, so B, it is not considered to have rotational symmetry. Let us examine the rotational symmetry of an equilateral triangle. Okay, equilateral triangle, a rotation, its angle of rotation, okay, the minimum angle through which a figure has to be rotated to get the original figure is called the angle of rotation. Okay, equilateral triangle, its angle of rotation is 120 degree. If you rotate it by 120 degree, you see we get this figure which look exactly as the original. Again you rotate it by 120 degree, it looks exactly as its original. Again you rotate it by 120 degree, it looks exactly as its original. Okay, so the equilateral triangle fits onto itself thrice when rotated. Okay, thrice. You rotated 120 degree, you get this, which look exactly as its original. This is 1. Again you rotated 120 degree, you will get this one. This is 2, which look exactly as its original. Again you rotate it by 120 degree, you will get this, which look exactly as its original. So the equilateral triangle fits onto itself, okay, fits onto itself thrice when rotated through an angle of 120 degree, 240 degree and 360 degree. So it has a rotational symmetry of order 3. Okay, it has a rotational symmetry of order 3. Okay, so I hope you have understood. So you see figures having both line and rotational symmetries. A rectangle has two lines of symmetry, namely the lines joining the midpoints of its opposite sides. Okay, it has two lines of symmetry. It also has a rotational symmetry of order 2, which looks exactly the same when rotated through an angle of 180 degree and 360 degree. Okay, a rectangle has two lines of symmetry, namely the lines joining the midpoints of its opposite sides. It also has a rotational symmetry of order 2, which looks exactly the same when rotated through an angle of 180 degree and 360 degree. Okay, a rectangle, if you rotate it through an angle of 180 degree, okay, you will get the rectangle that you will get, it will look exactly as its original one. Okay, and in 360 degree also you will get the rectangle which look exactly as its original one. Okay, so a square has four lines of symmetry, namely the diagonals and the line joining the midpoints of the opposite side. It has a rotational symmetry of order 4, which look exactly the same Square, if you rotate it by 90 degree, it will look exactly as its original. Again, if you rotate it by 90 degree, that is total 180 degree, it will look as its original. Again, if you rotate it by 90 degree, it will look as its original. Again, if you rotate it by 90 degree, it will look exactly as its original. An isosceles triangle has a line of symmetry but does not have a rotational symmetry. Okay, an isosceles triangle has one line of symmetry but it does not have rotational symmetry. A circle can be rotated through its center through any angle and has unlimited number of lines of symmetry. Okay, a circle, unlimited number of lines of symmetry. That means circle, if you little bit also, if you rotate it, it will look exactly as its original only. Okay, so therefore a circle can be rotated through its center through any angle and has an unlimited number of lines of symmetry. The center of the circle, that is diameter, forms a line of reflection symmetry and has a rotational symmetry around the center of every angle. Rotational and reflection symmetry. The regular polygons such as equilateral triangle, square, regular pentagon and regular hexagon have both reflection and rotational symmetry. However, there are certain figures which show only rotational symmetry. For example, are given below. Okay, this type of figures which show only rotational symmetry. Okay, it shows only rotational symmetry. Okay, so a regular polygon such as equilateral triangle, square, regular pentagon and regular hexagon have both reflection and rotational symmetry. Okay, however, there are certain figures which show only rotational symmetry. Some examples are given below. Okay, so some figures show only rotational symmetry. These type of figures show only rotational symmetry. Okay, letters such as A, vertical, it has vertical line of symmetry, and C, horizontal, it has horizontal line of symmetry, shows only reflection symmetry. Okay, this shows only reflection symmetry. Some figure possesses neither reflection symmetry nor rotational symmetry. Okay, these type of figures, they neither have reflection symmetry nor rotational symmetry. So I hope you have understood. From our next video, we will start exercise 15B. Okay, thank you.